So, ladies and gentlemen, we welcome you to our webinar at GTT. Today, GTT, together with the Bureau Veritas and the Hamburg Ship Model Basin HSVA, we will present you the design and development of the shearwater, ballast-water-free LNG feeder and bunker vessel. This webinar is just an introduction. It's a starter, if you want, or appetizer. We know that, and knowing that, we would be very pleased to get your interest and hear more from you, even after our Q&A part at the end. You may contact us at any time via the address shown already here, and later again, commercial@gtt.fr. And of course, also via our website. And please feel free to use the Zoom Q&A button for questions right from now, already during the presentation. And further, this webinar is being recorded and can be reviewed later via our website. Now, presenting shearwater, introducing Julien Boulland, Bureau Veritas, market leader, sustainable shipping, and Dr. Manasés T.Ruiz from HSVA, researcher in ships, and myself, Lorenz Claes, GTT naval architect. Now, Julien will give you a short introduction into the topic. Please, Julien.
Thank you, Lorenz. So you can hear me? Yeah.
Yeah.
Okay. So hi. So good morning, good afternoon. So my name is Julien Boulland. I represent Bureau Veritas. So ballast water is used on almost every ship today worldwide since a very long time, with the largest use of ballast water on deadweight ships when those are in empty conditions in order to reach sufficient draft and reduce the slamming. The issues associated with ballast water are numerous. Environmental, water pollution in way of invasive marine species, increased exhaust gas emissions because of power demand, operations, systems are not always working properly, and cost, CAPEX, OPEX, corrosion, maintenance, lifetime. So to combat the environmental pollution, the IMO now mandates, since some years, 2017, a mandatory ballast water treatment system to be fitted on board. So although the Ballast Water Management Convention has set criteria for ballast water treatment to limit the risk of unwanted invasions, these requirements entail significant investment in onboard system and additional costs for operation and maintenance. So the photo you see here is a typical LNG carrier in ballast water overflow operation. There are typically over 50,000 cubic meter of seawater on board for this type of vessel. Can move to the next slide.
Mm-hmm.
So going ballast water free yields many advantages. So we have put here the 4 key topics. So first, IMO Ballast Water Management Convention requirements are not required anymore. That's number 1. Then you have improved operation. Basically, you don't have any ballast water management on board, no hassle for the crew. Then looking at the cost and the cost for society, and here I mean in way of greenhouse gas, so CAPEX and OPEX. So in terms of CAPEX, construction cost, the first estimates show a reduction of 5% due to the absence of ballast water system, pumps, valves, pipes, smaller sea chest, and there is no ballast water treatment system as well, and a reduction of air vents and sounding pipes control. Then when we look at the OPEX, you reduce the operating cost between 100 to 200,000 USD on a yearly basis due to fuel consumption reduction, due to lower displacement while the ship is empty, a reduction of power demand due to the elimination of the ballast filling operation. Maintenance is also reduced due to the elimination of tank coating, tank anodes, and no sediment to handle. Then from a greenhouse gas perspective and shipping decarbonization, a reduction of 10 to 15% of emission is also envisaged, depending on the ship type, which is a significant feature in the shipping decarbonization conversation. So these advantages are reflecting the problems you encounter when carrying ballast water on board. Now I hand over to Lorenz, who will share on our ballast-free project, starting with the genesis.
Yeah, Julien, thank you very much for this little introduction to the topic. Here we are looking a short time back. This is our previous slightly bigger project from 2018-19 called Be Free for Ballast Free. This is a single screw 28,000 cubic meter LNG feeder vessel. This project was put on hold because the market was low. However, we obtained very promising results, and GTT decided to push further with a new design, having an LNG capacity close to the current LNG bunker vessels. And here comes the Shearwater then. We wanted to prove that such a new design is safe for navigation in all conditions. And the various advantages can be combined in an always fully operational and sound ship design. And just for explanation, Shearwater, our project name, this is a seabird of the petrel family, performing long migrations and long living. So that's just as we wish it for a good vessel. And this is a general concept, a 140-meter vessel for a capacity of 18,700 cubic meter and 2 identical LNG tanks. The DFD power plant supplies all consumers, including the 2 azimuth thrusters of 3 megawatt each. And you will note 2 key features. The first one is an anti-roll tank installed forward. This ART is new for LNG carriers, but already well known and proven on many other ships. And secondly, a trim system operated with permanent onboard freshwater. You see the accommodation block is situated aft for about 20 persons. And you will note also that the hull lines here are drawn without a bulbous bow, which improves the trim behavior of the vessel. Cargo systems will be similar to existing bunker vessels. And the midship section in a so-called V shape. On the left, you have the conventional vessel, and on the right, the shearwater section. The principle is to increase the design draft in order to keep always sufficient draft, even when empty. This shape leads to a smaller block coefficient. And as you see, the membrane tank geometry is ideally suitable and perfectly matching the shape without losing space. We have provided a large bottom plate, which allows risk-free standard docking operations, even with this V shape. You see the bilge keels situation and size. All this was investigated with HSVA for the optimum situation. And you will remark the draft difference between full and empty, which is of course higher than on a conventional ballasted vessel. And our funnel logo, which is reflecting the concept. Inside the vessel, we have designed the membrane system of Mark III flex type, 400 millimeter thickness. This gives a boil-off rate as low as 0.165% of volume per day, without filling restrictions, and this in worldwide operation. Our test campaign has been done. We come to this later. And the campaign confirmed the foam densities of standard 130 and partly 150 kilograms per cubic meter. This is slightly better than the previous design we have made. Now, there are a number of specific issues on such a design. We have, I believe, addressed all the specific design issues. Important input for the hydrodynamics was given by HSVA from the very beginning, including CFD calculations before building the model. And Manasés will show us key moments from the HSVA campaign a bit later. You see items like trim and propeller immersion, rolling behavior. All this were deeply investigated and found to be acceptable. To mention one specific issue here, the pilot boarding operations, that seemed to be a showstopper in the beginning. So we tested this and it showed to be without problem. I have a picture on this later. If you're interested to know more about all these questions, of course, we can set up a dedicated meeting with you to dig into all these questions. And here is a data sheet which summarizes the project. That's a proposal at this stage. The technical specification can be further adapted to meet specific owner demands. You can imagine typical items are, of course, speed, power, and the installed engines, the range on MDO, for example, the autonomy with 4,000 nautical miles, which gives you transatlantic transfer possibility, and accommodation layout and equipment type and sizing, etc., etc., etc. So there are many questions in the specifications, of course. This can be made together with a ship owner which is interested. Now I would like to hand over to Manasés for the testing part at HSVA.
Thank you, Lorenz.
Yeah.
By the end of 2019, a cooperation agreement between HSVA and GTT was signed. The main goal was to investigate the hydrodynamic behavior of such a new design, with a special emphasis on its seakeeping response. Additionally, the model was equipped with one integrated LNG tank to gather data for the correlation between ship movements and tank liquid motions. Here we have some views of the self-propelled model. Note the substantial dimensions and weight of the twin propulsors and the LNG tank. In the forward part of the vessel, an anti-roll tank, commonly known as ART, is also installed. This can offer a roll reduction of about 15 to 60%. In practice, the vessel can always be operated without using the ART. The model investigations started with a speed power test, evaluated for a design speed of 14 knots. Tests were conducted at the design and empty draft. 14 knots design speed is considered as reasonable in terms of power demand and consumption. Some relevant aspects from these investigations are a 20% sea margin is used for the propulsion design point. A comparison with the conventional vessels shows average improvements of 10 to 15%, depending on the considered range. Bear in mind that in practice, bunker vessels are normally operated at lower speeds at this point. This will be subject to further discussion with the owner. Speed of 14 knots is suitable for use as LNG feeder vessel, operating on higher speed than a bunker vessel. The maneuvering investigations show excellent results, both for course keeping and turning ability. IMO criteria were satisfied with a good margin. In both conditions, design and empty draft, the vessel showed very good maneuvering performance. A really important question was how does the vessel perform with respect to seakeeping? This was the central question in the project development. A few examples of the large number of tests are shown on the next slides. Here you can see the vessel investigated in two different conditions, run number 9 and run number 250. On the top figure is the test conducted at 60% full cargo, no active anti-roll tank, and tested at a significant wave height of 4 meters in both quartering waves. Below is the test conducted at the design draft at 10 knots at a significant wave height of 5 meters in head waves. Among the large number of tests conducted, investigations such as the filled LNG tank in operation, see bottom right corner of the slide, or the pilot boarding condition, see bottom left corner of the slide, were also investigated. After the intensive test campaign, the findings from the seakeeping investigations are: no excessive or dangerous phenomena occurred, observations are similar to other ships, and parametric rolling was not an issue due to the specific hull shape. For the general hydrodynamic investigations, we can summarize that the ship regarding speed power, maneuvering, and sea keeping present a very good performance. Now, I hand the presentation to Lorenz, who will introduce you more to other relevant aspects of the ship design.
Yeah, thank you very much, Manasés, for this inside view of the testing part in HSVA. Now, besides the work done by HSVA, GTT has performed another test campaign, their own full sloshing campaign in our own laboratory. On the left, you see the GTT testing, and in the upper right, the HSVA model tank. You can see similarities, of course. The green color, that is some coloring we HSVA put into the tank for better viewing the movements, which is not done in GTT tank because we are in clear visible tank model. So you can see a picture of Mark III membrane. You can see the plan of the tank. You can see a screenshot of the test campaign with this model tank and the view inside of our labs and the shearwater tank on the hexapod in operation. We had good results, and these test results confirm that the containment system is well matching the initial design requirements for the vessel. You see it here in 3 words: no filling restrictions, worldwide operation, low boil-off rate. Now, what about another size? We believe key results can certainly be used to a certain extent on bigger or smaller ship sizes. You can see here some we have imagined. We have been on the 18,700 here. We have a concept on the 12K size. In principle, the only physical limit would be a draft restriction of such a design. At this stage, ballast water-free vessels of moderate size seem to be more realistic than the large carriers. Let's see how the market is developing. However, already today, considerations are ongoing also for larger vessels. And second question behind, what about this use of the same principle for other ship types, such as medium-sized bulkers to start with, tankers, container feeder vessels, and some other ships possibly. We all at Bureau Veritas, HSVA, and GTT, we are very open to further discuss this question with you. And now I hand over to Julien for the part of Bureau Veritas. Julien.
Thank you.
Hello. Cannot hear you.
Now you can hear me.
Yes.
Okay, sorry.
Good. The floor is yours.
Okay, so let's go to the involvement of Bureau Veritas. So in the next few slides, I will describe the involvement of BV in the approval in principle of the design, and I will recall some important information related to the LNG bunkering segment. So next slide. Okay, so LNG bunkering. So first, I would like to highlight the deep engagement of Bureau Veritas in this specific market segment with the classification of the first ever tailor-made new building, but also conversion. Previous and current assessment include different types of containment system and a wide range of cargo capacities. In addition, BV has developed specific skill set, tools, and guidelines for the sloshing assessment and risk analysis which were very important in the field of membrane LNG tanks, such as LNG carrier, LNG bunkering vessel, and LNG as fuel application for the marine industry. So just as an example of our involvement in this segment, we class the largest LNG bunkering vessel with membrane containment system currently in operation, and there are 2 vessels like this. And finally, I highlight that BV currently holds around 40% of the market share in terms of classification services. So next, when we come to the regulatory framework, so in relation to the LNG bunkering vessel industry, I would like to highlight the main regulation and guidelines in place for the assessment of this type of ship. So in addition to the well-known international IMO regulation mentioned in this slide, IGC code, BV has developed a rule note to cover the specificities of LNG bunkering vessel to satisfy the demand of different stakeholders, such as port authority, charterers. So the name of our guideline is BV NR 620. In order to follow industry development, just to let you know that we have also overhauled completely in July 2022 this rule note to cover the LNG bunkering transfer and also to include the latest standard commonly used in such transfer system. And finally, to mention that other documents available are also used in many cases to give green light for LNG bunkering project to be developed. Now, further on our BV involvement, when it comes to the approval in principle, so taking into consideration the significant experience in this field and more specifically in membrane containment system, GTT has requested an approval in principle to BV to give the necessary confidence and assurance for further development of the design. This approval in principle was based on the mentioned international and class regulation, and the certificate was issued this year in March. Then when it comes to our involvement, so to finalize, I would like also to highlight the significant feature of this approval. So the concept design includes a comprehensive list of documents, including, so I will not go through everything, but basically just to let you know that we have reviewed outline specification, the general arrangement, machinery arrangement. When it comes to stability, the trim and stability booklet, report on liquid movement, hydrodynamic studies and testing campaign at HSVA, maneuvering and course keeping performance also at HSVA, the cargo handling system and the EDI report. So the design was found in compliance with the regulatory framework, and a valuable list of comments was issued by BV to help GTT to go further with the design. So for the next phase of the engineering, next phase of development of this project, we mentioned that an additional assessment on slushing will have to be carried out, in addition to an assessment of the LNG transfer system in order to complete a full approval of this design. Thank you. And I hand over to Lorenz.
Yeah, thank you very much, Julien. To sum up here, all this work, here are the key takeaways and some points only. Hydrodynamics, good to excellent. LNG tanks with low boil-off rate and worldwide service without restrictions. CapEx can be lower by about 5%. OpEx is expected to be lower by 10 to 15%. The class approval just mentioned by Julien in principle is obtained. And the key point here, of course, environment and emissions, it marks a real good step forward. So basically, we are ready to order. That is a key point. And now we would like to open time enough to have question answer part in this webinar, and in parallel some online poll where we invite you to answer some questions which will be interesting for all of us, I believe. And we try to evaluate that after some time. So please feel free to put forward your questions. We try to answer as possible, as good as possible. And you can scroll through the polling. So Julien will be our moderator for the question and answer part. Maybe we have already some coming up. And have you some coming in?
Okay, so we have some questions coming in, so feel free to ask your question and we'll try to endeavor to reply. So we do have some questions coming up. I think one is for Lorenz, but I think it was already mentioned. Cost reduction, how big are the cost reduction?
How big? There are some cost reduction which have to be confirmed by a firm offer from the shipyard, of course. We expect what we have seen about 5% less capital cost. So due to the systems which we don't need anymore and the simplification of the vessel. So about 5% should be possible.
Okay, thank you.
Yeah.
So there is a question I think would be for Manasés or for Lorenz, maybe. It seems the wet surface is increased compared to with conventional midship. Why the ship performance gets better? Who wants to take this one?
Either myself or Manasés. What do you think? Can be in easy way? I can maybe take this. It's one key point is when the vessel is empty, we will not carry as for a conventional vessel about 6,000 to 7,000 tons of water over the ocean. So the vessel will be lighter by easily 6,000 to 7,000 tons compared to a conventional vessel. In such a point, we can even have about 25% reduction in power in this particular point. So we say we will have an average gain of 10 to 15% if you make the average between full and empty over the speed range. That is the way. I hope this was clear enough. But so even in spite of this slightly increased wetted surface, we have a big advantage actually. That is the point. Yeah.
Okay. Thank you. So we have another question. So how do motions compare with a conventional ballasted vessel, in particular in terms of crew comfort? Has the design been assessed any particular crew comfort standards and guideline?
Same Manasés. It's, or I can take it also. It's up to you. We have been talking about NORSOC criteria, and we have this anti-roll tank, which can significantly reduce the roll movements. And of course, there are strong movements in some cases, like on any other ship. And we are, I would say, quite comparable to such other vessels. That's what I can tell you today. Otherwise, we have to really dig into the details. And
yeah, what I can add perhaps is like no particular event that could be reported as dangerous were observed during the entire test campaign. So that's something we can just answer right now. But if you want in a specific detail of how much and was this, we can of course discuss that later on with a technical document at hand. So
okay.
Thank you.
Some more,
So there is a question, I think, for GTT. So I think it's linked to your GTT license in the yard. So from a ship owner perspective, we speak to the yard and we pay them, not GTT. When you say ready to order, does it mean you have a list of yards that can build this?
Yes, we have our licensees. As we can discuss which one, and in principle, any licensee can build it if the slot is available. And we can also go to any other good shipyard using our model with a licensed outfitting company. So we could build it also in Europe if you prefer, as we have demonstrated before with typically the Boulland project. So there are a number of yards available to build it. I must admit that slots at the moment are difficult to get. So there is, but this can be investigated directly with the yards.
Yeah. Okay, it's clear. So we have a question regarding ice tank at HSVA. Are there any plans to conduct some tests regarding ice tank at HSVA?
I think Lorenz would be maybe the one. I don't know. whether you have been in contact with the guys around here, and maybe Lorenz, you can come up with this.
Well, maybe I did not really get this point.
Yeah, I was just wondering what the question is, but
Can you repeat? What is the question with ice tank here?
They say, are there any plans to conduct some tests regarding ice tank at HSVA?
well, we have an ice tank, so that's.
I think the question is: will you do the design testing in ice condition
Could
in
be.
the ice tank? I think
Could be
that's
something like this.
the question is like this.
For this project here, that is at the moment not foreseen, but of course we can discuss if it makes sense or not for the shearwater project.
Yeah.
Okay.
So far, it's not. There's no ice class foreseen for this vessel, but if we would like to have Baltic capability, then of course we need ice reinforcement, and we could even imagine ice testing. That's of course possible. Yeah.
Depend on the demand. Yeah. Okay. Thank you. We have a question. During the seakeeping test, what was loaded in the LNG tank?
Yeah, it's actually water. It's a color water that was actually one of the things that Lorenz mentioned before. The color was green, so it looks some kind of algae thing. So it's nothing bio. So it's just a color on the water that we add in order to visualize better the motions of the fluid around the tank.
So it's water. Okay.
Yeah, it's just water.
So we have a comment, a compliment. Thank you.
Yeah.
Great presentation. And a few questions.
Thank you.
Thank you. Can you expand on the trim tanks shown in the double bottom? So that's question number one. What is the draft in the empty condition? Question number two. And you have mentioned the intention to scaling up this concept to other solutions. What are your plans to control the longitudinal strength in the empty condition? So first question is, can you expand on the trim tanks shown in the double bottom?
Yes, basically trim tanks, we have a certain quantity of fresh water as trim water on board, which can be taken from forward to aft and vice versa. And we can also imagine to store this trim water in the center part of the ship when it's fully loaded to reduce bending moments, if you want. That is one aspect. And that's basically all. Yeah. So we need trim water to limit the trim within the requirements. Basically, we have even keel in fully loaded condition, draft 7.25 design draft today. So even keel when fully loaded, and when the vessel is empty, we have about 1.5 meter trim aft. That is for better immersion of the propeller. And in this condition, we need trim water pushed forward. So we could even go to 2 meters aft trim to be compliant. But basically, we will have about 1.5 meter trim aft with about a good 4 meter mean draft, 4.5 to 5, depending on the final loading conditions.
Okay, so that answered the second question, which was the empty, the draft in empty conditions, so 4 meter.
And
then scaling up, do you have plans to scale up to a larger vessel? And what is your plan to control the longitudinal strength in empty condition for this larger vessel?
Yeah, first longitudinal strength. There's no major problem expected for membrane vessels. We have a full double hull with a high depth of the vessel, so longitudinal strength normally is not a problem, and it's easy, straightforward engineering. That will be not a major issue. And scaling up or down, we showed here 25,000 cubics. The question is how far we can extrapolate results. This we can discuss more in detail with HSVA. And then we are, of course, considering much bigger ships. At one moment, we are hurting the draft restrictions if we talk about LNG carriers, which are normally around 11.5 to 12 meters. And if you want to use this principle with more initial draft, more design draft, then of course the design will be different and the problems will be slightly different. They will shift a bit. So, but we can, if there's more precise request, we can of course discuss this in a dedicated meeting. Yeah.
There's a question which is not asked, but I will respond. Is the fatigue assessment of the hull also? This is that will need to be assessed. But
yes, but this is for this vessel size. Don't believe it's critical.
Yeah.
If we go to bigger sizes, it's certainly to be done. Also with this one, but it will be done. This was not yet done on this design. I agree.
And then we have a question which is similar. Do you envisage any structural issues with no cargo condition without ballast water? Do you see the stress in the hull to be greater in this condition? Would there be an increase in longitudinal bending moment?
I think it's rather lower because we have a quite long prismatic body of this vessel, which is due to the shape we wanted to generate. And basically, this principle will slightly reduce bending moments. One issue, of course, will be talking about structure and strength, will be slamming reinforcements. We had slamming sensors, one fore and one aft, and did not discover excessive slammings. In any case, there will be slamming reinforcements, especially forward. However, we have a real V shape, especially forward, and so the flat bottom part of such a vessel, it's clearly smaller than on any other ship. So yes, there will be some slamming, but it is easy to come around this problem, and basically will not be worse than on other ships.
Okay, thank you. So we have more questions. In case of damage condition, so I think it's stability, what conclusion you have achieved and countermeasure taken into consideration?
Damage stability is quite straightforward. I proposed, I've written that in our specification of the vessel that, this vessel is shorter than 150 meters, and the code would permit to have a single status compartment status for the machinery part. And we have checked, you can even damage the forward bulkhead and the separate forward and aft machinery bulkhead. That means you can have a full two-compartment status over the vessel length, which is more than required by the rules, but in my view is essential for such a vessel.
And damage stability was part of the approval in principle.
Yeah.
Thank you for all these questions. We have more questions coming up. We have one on IP rights, intellectual property. I think this is for GTT. Is there any patent on this design?
Two things. The principle itself cannot be patented because there were many publications over the last, say, decades. Many people have investigated this problem. We have some patents pending, actually, on some systems on board, covering things like trim system and related issues. But in itself, it cannot be patented. So that is basically what we can say here.
Okay. There is a question, I think, which is for Dr. Manasés. It talks about parametric roll. Have you investigated parametric roll for this campaign? For this design?
Yes, the accommodation study was that the vessel does not suffer from such an event. So we have, during the extensive test campaign, we could not observe such a behavior. And the reason mainly behind it is, if I can summarize, is just mainly because of the shape of the hull. So the particular V shape of the hull just allows that such a phenomena can be far away from what is usually observed in conventional vessels.
Okay. Okay. There is a question also, I think, again for Dr. Manasés. What was the model scale, and can you share some detail on the scale of the model?
Detail specifically, I mean, The scale was 18.12, so this led to a ship model of a length of 7.75 meters and 2.8 tons. That's the main things I can say, but yeah. You can ask perhaps Lorenz for the technical report and it will have much more detail.
It was a big model, yes. It is a big
definitely.
model. And maybe just to add, it's still available at HSVA. So if anybody wants to see it or do more testing, we can discuss also that.
You can always pass by and look around the model if you like.
Yeah.
Okay, there is a question, I think it's for me. They say, could you elaborate a little bit more on the interest of this solution regarding ballast water management convention? Yes, so as was highlighted in the presentation, actually, when you remove the ballast water from the ship operation, so it's really a key feature from a regulatory perspective as well. So the compliance with the Ballast Water Management Convention can prove to be difficult. This is what we see in particular with this new ballast water treatment system. I'm not pointing figure, but we know that they can be proved difficult to operate. It's not that easy to find a proper system. The issue of non-compliant system does exist. I'm not disclosing any hidden truth. So hence a ballast-free ship is definitely interesting feature from a regulatory perspective in that respect. So we have a little bit more some question. There is a question I think is for GTT. It goes like this: for feeder services. So when you need to do ballast operation, the advantages are obvious. But is there a real advantage for bunker vessel that will basically operate in the same zone?
That is the question we had on the table. And yeah, of course, you can argue that on bunker vessels, maybe the administration will allow not to install a ballast water treatment system because you're always operating in the same zone. But at least you can be sure that you will simplify your life in any case if you don't need this ballast water all the time to take it in and out. And so it will help in both cases a lot, of course. And it will give you more flexibility in case you will change the area. Today, we can see typically I've one bunker vessel in mind, which is operating in Baltic Sea, in North Sea. And apparently this vessel came down to Atlantic side to make other bunker operations. So the range of such vessels can still be quite long, actually. So you have to consider seriously if you can skip a ballast water treatment or not. That's a key question, of course.
Okay, thank you. So there's a question about pilot boarding. Can you give more details about pilot boarding?
Yeah, pilot boarding was a headache in the beginning because then people said, okay, you have this V shape when you're empty. You may smash into the pilot boat. And so what we have done is, you have seen it on one of the small photos. We have taken a small model, which is same size as a pilot boat compared to the ship. And we have towed it in the conditions as pilot boarding conditions, 20 degrees heading against the sea. And we wanted to see if there's a lot of contact, strong contact points, so crashing into the boat. And it did not happen, actually. This is a point which has to be re-evaluated if you go to very big ships and to see how it comes along. Then behind that, we investigated this standard pilot boarding by boats. But there are other methods also which can be discussed, of course, and several other methods to avoid pilot boarding can also be discussed. But this is not our business. We wanted just to show physically it can be done, actually, and it was the case here. No bad surprise, actually. That's what we can say.
Okay. Thank you. So there is a question on lines plan. Parallel body length at empty condition would be expected shorter than conventional vessel.
No,
Do you have any opinion?
It's even longer. We have quite a long prismatic mid-body, and it's rather longer. At least the underwater part is longer than on conventional vessels, which is slightly penalizing for speed power. Not much, but possibly a bit. On the upper part, if it comes to contact points for the terminals, it's pretty much the same than any other bunker vessel. So you can see it on the GA plan, and there's no difference. So this vessel is drawn as same capacity as a gas agility vessel, but made slightly longer for better performance and easier trim management. So this vessel is 5 meters longer than the gas agility for these reasons. Yeah, that's maybe.
There's a lot of question on the lights plan. Huh?
Yeah,
it's
good.
From naval architecture perspective.
Yes.
Yeah, that's the key point. Huh?
Yeah.
Shape of the hull.
Shape of the hull. Yeah.
Thank you for the question. So we have another question related to ballast water. So ballast water operates internal only, or do you throw it overboard and you take in water?
No, what we call a trim water, we propose fresh water permanently on board. And I would even go one step more, say better use even distilled water, then you are totally out of any corrosion issue. And it will be permanently on board, and it can be taken out every 5 years if Bureau Veritas would like to inspect capacities. And,
probably.
Yes, but otherwise, you can even pump it to the other side and then even keep it on board in that case. So basically, it stays on board all the time, and it will also be used for operating the anti-roll tank in these conditions. So the advantage here is that the anti-roll tank operation will not reduce the dead weight of the vessel. We just use the same fresh water for that.
Okay. There is everything is interesting, obviously, but here we have a question on conversion. Conversion of existing ship. Can this new design be applied in principle on an existing ballasted ship? If yes, any further plan to convert from a conventional ship to ballast-free ship? Interesting and complicated, I presume.
Yeah. I don't think we can immediately convert the ship into a V shape. I mean, many things have been done, and I've even seen a widening of the container vessel, cutting longitudinal to wide it. Conversion people are genius people. They can do everything, but is it worth to do it? I'm not sure. It could be the case. But I really would say here, let's discuss it on case by case. I would hesitate more than one time.
Engineers will be happy to work on that, right?
Of course, you can do everything, but if it's financially interesting, I'm not sure.
No, it's a really interesting question, yeah, in terms of concept, yeah.
Could be done, of course, if you increase maybe the beam slightly to make it this way. But is it really interesting to do this? I have some doubts. Okay.
So we'll take one more question, and after we'll do the poll. So the one question we have: is heating required all around the tanks, or only cofferdam as conventional LNG carrier?
Yeah, very good question. So far, we are on the central cofferdam heating, not the surrounding part. So quite classical approach. But this will be, of course, in case of water, will be clarified, and that is our job at GTT to give you the technical specification for that.
Okay, so if the rest of the question will be answered, I mean, directly, but now we can move to the poll. So
yeah,
yes. So I think it will be interesting to see what the results show up right now from our quick poll. So I will read them and then ask maybe one of you to comment on that. So The first one is Ballast-Water on board and an onboard problem? And yes, as a big problem, with 50% of our attendants saying that this is a major problem. But do you have to comment on that, Lorenz?
Yeah, that confirms pretty much our thinking that we know it is a problem. I believe that it's of course very much depending on the ship type you're operating. Some ship types don't have much ballast water on board, then it's only a small problem or no problem. Yeah, but it's for cargo ships. It basically confirms there is a problem. So that's good to know actually that people think the same way as we do.
Yeah, and we have 95% of our attendants replying that is a ballast water free vessel, a commercial plus for your company. So are you surprised by that, or?
I will a bit, yes. 95 is a high score. So that really pushes us to continue this this type of designs. Really, I should make a screenshot here, and I will keep the results anyway, and I will also share this with my colleagues. Yeah, it's very much confirming that we're on the right way, actually.
And we see that actually there is no one who says that they wouldn't go for a ballast-free vessel. Most of them, almost 100% of them, they say yes, or maybe they will go for a ballast-free, water-free vessel.
Okay, yeah, very encouraging results here actually, and I'm happy that we asked you these questions to the audience. So thank you very much. And the next.
So how do you consider the design that was asked to our audience, and they reply excellent, good, interesting, with good percentage, say.
Good. Thank you for replying. So clearly on the upper part of the I think it's honest, and so I'm very pleased to see the results.
And this is also a very interesting one. What capacity is of interesting for your company? So you have 5 to 20,000, with most of them replying in that range.
So actually we have all the ranges here. That's good to see. And we have two peaks. Okay, 5 to 20 is quite a big range. And then yeah, it's interesting also what we are just touched as a topic. Over 50K is also of major interest and more difficult to make actually, but that shows we have to work on this. And yeah, at least we really can say thank you for replying to these questions, and we will certainly consider them the results again and see how we can continue such developments. Yeah. Okay. Anything else here at this point, or shall we move on? I think so.
I think so.
Yeah. So then, before it's not moving here. Yeah, here's moving. Before we close this session here, I would like to announce our next webinar. We would like to dive with you into this landmark project here, an onshore membrane tank of 29,000 cubic meter, which was recently commissioned in China. And you can catch up with us how this first of a kind reservoir sets a new technology reference for the world booming land storage market. We will send out the registration link very soon, and you can join us on November 29th or December 1st. So if you're interested here, please join. Yes, and so we can conclude here this webinar after navigating 1 hour entirely ballast water free over the oceans. We have to conclude here, and but we are certainly not at the end of the story. We have seen these polling results, which are very interesting for us and show we are on the right track. So thank you very much for your time spent with us and your kind attention. We hope it was and remains of interest to you, and we do hope to hear again from you in the near future. I can mention here that we have put a little film of 4 minutes on YouTube. You can type YouTube tag GTT Shearwater and you will find it easily. And I take the occasion also to mention 2 companies having provided valuable project input. That's namely Hoppe Marine for the anti-roll tank and Shuttle for the azimuth thruster propulsion system. And of course, I would like to thank very much here Julien Boulland and Manasés T.Ruiz for co-presenting this project. So now Julien, Manasés and myself, we can say goodbye and keep the ocean in the ocean.
Thank you.
Thank you.
Bye-bye.
Thank you. Have a good day.
Bye. Bye, everyone.